What we're going to talk about now is how to solve these equations when they have a fraction up in the power. So I had to do that little practice warm-up that was all about reciprocals, right? 1/2, the reciprocal is 2/1, or just 2. If I had 3/10, the reciprocal is 10/3, and so on. And then when you looked at some of the examples and you saw something like x to the 1/2 raised to a second power, that was multiplying those together, 1/2 times 2, calculator if you need to, that equals 1, which means that becomes x to the 1. And that idea right there is how we're actually going to solve these equations. So first steps first is you got to make sure that that exponent, this guy, is all by itself. The thing being raised to the power has to be all by itself. Then you're going to put parentheses around the exponent. So I'm going to write it as x to the 1/5. And then you're going to write the reciprocal of that power on the outside. So 1/5, the reciprocal is 5/1, or just 5. So I'm going to put a 5 out here. Now remember, the rule with equations and solving is that if you do something to one side of the equation, you've got to do the same thing to the other side. So I'm also going to put parentheses around that, and I'm going to put that little 5 power out on the outside. Whatever you do to one side of an equation, you have to do the exact same thing to the other side. And the purpose of that was, now if I take x to the 1/5 times 5, 1/5 times 5, it's going to equal 1. So this just becomes x to the 1, which is really just x, we don't need to write the 1, equals 2 to the 5th. Boop, boop, boop. Calculator says then that x equals 32. And that's been solved. Now this next example, if you look closely at it, this is the thing being raised to the power. He is not being raised to the power. That 4 there is out of place. So how do we get rid of a 4 when it's just written out front? Well, if there's no plus, minus, or divide, then you assume it to be multiplication. So to get rid of it, I've got to divide by it. But whatever you do to one side of an equation, you have to do to the other, which leaves us as x to the 1/3 equals -3. Okay, now I'm going to change it so that I can get rid of that 1/3 power on the x. I'm going to write in the parentheses with different colors. So I'm going to put parentheses outside here, and the reciprocal of 1/3 is 3, or 3/1. Now since I did that to the left side, I've got to come over here and do it to the right side. That left side just turns into x. We picked the power to make that do it. And then this side is -3 to the 3rd power. Boop, boop, boop. Calculator says that's actually -27. So key to this is this step right here. You have to do the exact same thing on the other side of the equation. You're going to give it whatever power you gave this guy. Same power, the reciprocal power, and it goes on the outside. Whatever you do to one side of an equation, you have to do the other. And then solve whatever is left over for x. Sometimes you can use the calculator to actually find the final answer. Calculator when possible. What I mean by that is, like, -3 to the 3rd worked out, obviously, but not all the examples are going to have nice normal powers like a 3. For example, this one says solve the equation. All right. Is the exponent the thing being raised to a power alone? Yes. Okay. Our next step is to put parentheses around that guy and put a new power on the outside of the parentheses. Well, the reciprocal of 3/4 is 4/3. So I'm going to put the power out here of 4/3. Whatever you do to one side, you've got to do to the other. It's the exact same number, right? So then inside here, over here, I've got 3/4 times 4/3. It's a 4, not a 9. That will equal 1, which means this is now just x, or x to the 1, equals 27 to the 4/3 power. You can keep the parentheses if you want. Then when you boop, boop, boop that into a calculator, it tells you that that's actually equal to 81. Okay, and that's it. That's the answer to that problem. Looking at this next one right here, I've got x to the 3/2 equals 512. So I'm going to take x to the 3/2 and raise it to the reciprocal power. 3/2, the reciprocal is 2/3. So I'm going to put 2/3 out there. Now, since it's an equation, that equals 512, but whatever I do to one side, I've got to do to the other. I put that 2/3 power up there as well. Okay, over here on this left side, these guys would multiply and they turn into 1. So this is just going to drop down and become x equals, boop, 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 calculator says that that is actually 64. So literally in the calculator, I'm typing in 512, then the caret button, 2 divided by 3. If you want to be safe, put that in parentheses. But right about now, the caret button in the calculator always bumps it up into the power. Just make sure it's 2 divided by 3 up there. All right, this one looks different, but it's really not. This is 5 equals x to the 1/3. That's the same thing. If I switch sides, x to the 1/3 equals 5. Right? To get rid of that 1/3 power, I've got to put parentheses around it and put its reciprocal power over here. Now 1/3, the reciprocal is 3/1, which is really just 3. So I'm not going to write the over 1. Whatever I do to the left side, I have to do to the right. Okay, these guys cancel. Right, 1/3 times 3 is just 1. So I get x equals 5 to the 3rd, or 125. Right, one more example. This is x to the 3/2 equals 125. I've got to get rid of that 3/2 power. So I'm going to actually raise it up to the reciprocal power, 2/3. Have to do the same thing to this side. So now these guys cancel each other, and it becomes x equals 125 to the 2/3 power, which is 25. Boop, boop, boop. Calculator gave me that. I almost just asked if there were any questions. You couldn't ask me questions right now if you wanted to. All right, let's look at these. These have kind of been taking it up a step because there's more than one thing. It's not just x by itself. So let's look at this first one. This 3 right here is inside the parentheses with the x. So that 2/3 applies to both the 3 and the x. But the idea is still the same. In order to get rid of that 2/3, when you're solving an equation, you would just take it and raise it to the reciprocal power. But whatever you do on one side, you've got to do to the other. These are going to become 1, right? 2/3 times 3/2, 6/6, or 1. So this becomes 3x to the 1 power now. But you don't need the 1 power, so it's actually going to be 3x equals 9 to the 3/2. Boop, boop, boop. Calculator says that's actually 27. Now you've got this remaining equation. You apply regular old rules to it. To get rid of the 3, I would divide by it, and I end up with x equals 9. So again, one more time running through this. even though the 3 is in there with the x, that's okay. You still follow the same steps. Raise it to the radical power. Whatever you do to one side, you have to do to the other. This makes the power 2/3 go away. On the right side, it's 9 to that 3/2 power. Boop, boop, boop. Calculator says that's 27. Then you just divide by that 3 to get rid of it. It's a regular old equation. Once that fraction up in the power is gone, you solve it just like any normal one. Okay, this one, the difference is that 3 is not inside parentheses. It's only the x being raised to that. So instead of dividing at the end, I've actually got to divide and get rid of it before I can do the reciprocals. Right, so we have x to the 2/3 equals 3. Now you're going to apply the reciprocal to both sides. Okay, these cross out, that just becomes x equals 3 to the 3/2. Now, when you plug that into the calculator, it's not going to give you a nice normal number. So when I plug it into the calculator, it comes out to be 5.1961, blah, 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 blah. If it comes out to be that, I don't want the decimal. I would prefer this exact answer right here. The only time you'll give me an exact answer is if the calculator spits it out and says this is the exact number for that. All right, next one. This is x to the 5/4. There's my exponent. The problem is this guy right here, this -3. Regular old solving method says you can add that to both sides, get rid of it over here, so that now I have x to the 5/4 equals 243. Now, to get rid of that fractional power, I have got to put parentheses and write the reciprocal. Same thing to the other side with the exact same number, so that now these cancel, right? And it just becomes x equals, boop, boop, boop. Calculator now says 243 raised to the 4 divided by 5 power. It kicks out 81, so we can simplify that and say x equals 81. Okay, this next one, we've actually got a couple things to get rid of. If you look at it, you can see that there is this 2 right here. We know how to get rid of that now. You subtract it. Whoops. It's like I'm dividing. I'm not dividing. Subtract 2, subtract 2. 2x to the 3/4 equals 8. Now, the other piece of this is the 2. The 2 is inside the parentheses, so we can't do anything with it until we get rid of that fractional power. So here's my trick to get rid of the fractional power. I put parentheses, and I put the reciprocal power. Same thing to the other side, and those cancel, which leaves this left side as just 2x, and this right side is 8 to the 4/3. Boop, boop, boop. Calculator says that that's actually equal to 16. So I have 2x equals 16, solve like normal, which means divide by the 2 to get rid of it. This says x equals 8. So sometimes you'll be able to simplify it more, sometimes you won't. Okay, real quick, I want to go back to this one and just look at it a little bit closer. This 3 to the 3/2, if you remember, we can convert it to a radical now. So we could, that would be equal to n on the outside, a to the m on the inside. I say that because if we do that, you've got a square root, and then it's 3 to the 3rd, which means it's 3 times 3 times 3. Got a pair of 3's, so one's going to break out, and there's one left over inside. So this is equivalent to that. Now I say that because the answers would probably be written like that, and I don't want you to get confused. This one up here is not incorrect. It's just not in the proper form. I would accept either.